Hello, everyone. Welcome to our Data Protection Working Group session. My name is Xin Yang. I work at Veeam by Broadcom. I'm also co-chair of Kubernetes 6 storage and the Data Protection Working Group, working with Dave.
Hi, I'm Dave Smith-Uchida. I work at Veeam, and I hand it back to you.
Oh, yeah. So here's today's agenda. We're going to discuss what we have done for the working group, who are involved, what is the motivation for establishing the working group, and we will discuss some of the projects and the white paper that we are working on, and finally, how to get involved. Here are some key updates. We wrote a white paper on the data protection workflow in Kubernetes a while ago. We also recently updated the annual report for 2024. Here are some links to previous presentations at KubeCon. Here we listed companies who are supporting this data protection working group. In Kubernetes, the day one operations for stateful workloads are well supported. We have persistent volumes and persistent volume claims for the volume operations. And we have workload APIs such as deployment and stateful set for declarative management of your stateful workloads. More and more stateful workloads are moving to Kubernetes. These workloads moving to Kubernetes to take advantage of Kubernetes self-healing abilities, agile deployment, the built-in scalability and portability. However, day two operations for stateful workloads, such as data protection, are still limited. The GitOps workflow has limitation in supporting stateful workload. Secrets, config maps, and data stored in persistent volumes are not stored in the Git. So we need to have a better way to support data protection in Kubernetes. That's why we started this data protection working group. This working group is sponsored by both SIG Storage and SIG Apps. This figure shows the backup workflow with missing and existing building blocks in Kubernetes. The blue color shows the process. The green color shows existing Kubernetes components. Yellow means it is work in progress. Orange means it is a missing Kubernetes component. To back up an application in Kubernetes, we need to back up two pieces of data. We need to back up the Kubernetes metadata, and we also need to back up the data stored in persistent volumes. To back up data in the persistent volumes, there are two ways. We can either do a native data dump, such as MySQL dump, or we can back it up using the controller coordinated approach, where a volume snapshot is taken. To ensure application consistency, we first need to quiesce the application, and then we take a snapshot. After that, we need to unquiesce the application. The backup for both snapshot metadata, the backup for both the Kubernetes metadata and the volume data needs to be exported to the backup repository. The backup repository is a repo or location that you can use to store data and metadata. We see a few green color pieces here, and we have the application CRD that is owned by SIG Apps. We have volume snapshot that is owned by SIG Storage. Those are existing features in Kubernetes. We also have a few other features here. We have volume mode conversion that is targeting GA in 1.30 release. And this basically prevents unauthorized volume mode conversion between the file system and block mode when you create a PVC from a volume snapshot. We have consistent group snapshot moved to beta in 1.32. This allows you to create a crash-consistent snapshot of multiple volumes at the same point in time to ensure write-order consistency. We have cozy container object storage interface that tries to bring object storage as the first-class citizen in Kubernetes that can be used to manage the backup repository. That feature is still alpha. Now the team is trying to bring it to Veeam Alpha 2. We also have change block tracking feature that is targeting alpha in 1.33 release. And this provides a way to retrieve the metadata of change blocks between two snapshots to enable efficient backups. This figure shows the restore workflow with missing and existing Kubernetes building blocks. So to restore an application in Kubernetes, first we need to import the backup from the backup repository. Then we need to restore the Kubernetes metadata, and then we need to restore PVC and PV. If the volume was backed up natively, we need to restore from the native data dump. Otherwise, we need to rehydrate the PVC from the volume snapshot or a volume backup. We also have the volume populator feature here that is targeting GA in 1.33 release. This feature allows you to create a PVC from an external data source, such as a backup, that is not a volume snapshot or another PVC. So this feature is very useful during the restore time. So now let me hand it over to Dave for talk about the white paper.
Thanks, Xing. So we did a white paper previously on the need for data protection in Kubernetes. And now that we're wrapping up things like change block tracking, was like, what can we do next? And so what we're doing is starting a new white paper, and this one has two thrusts. We call it overall best practices for Kubernetes applications for data protection. That's kind of a mouthful there. It has two thrusts. One is to lay out how a Kubernetes administrator or user can set up their application for data protection, and then also to kind of call out what changes need to be made in existing Kubernetes applications and processes in order to support data protection. So right now we've got a lot of different mechanisms for data protection, and that's really good. And we've got different strategies that we can use, including GitOps, a backup restore, or replication. But then actually protecting an application, you need to understand your resiliency needs. You need to select the right strategy to meet those resiliency needs. And then you may actually have to modify your application to handle the strategy that you've chosen. So the white paper is under construction. I'm going to give you a preview of some of the areas we're working on. And we're looking for people to contribute, review, et cetera. So let's look on in. So when we start looking at a data protection strategy, we have to look at different factors and figure out what it is we actually need, because everything has a cost. So there's a couple of industry standard terms for data protection. That's the RTO, recovery time objective, and the RPO, recovery point objective. So RTO is how long is it going to take you to get your system back up and running after a disaster. So, for example, you may have to restore from a backup tape or S3 or something. And so however long that takes to bring the application back up is your RTO. RPO is how much data you could conceivably lose. So, for example, if you're doing a backup once a day, you could conceivably lose up to 24 hours worth of data. And so you have to pick, obviously in an ideal world, both would be zero. But there's costs involved. So you have to look at what your actual needs are and then weigh that against the costs of implementing the strategy. And then there's also the impact of data protection. So for example, I'll get into like the consistency stuff in a bit, but if you're taking a crash consistent backup, which is what we commonly do with snapshots, it's a very low impact on the application. But you're only crash consistent, versus if you need to quiesce the entire application during the backup process, the application is maybe down during that time. So you have to look at those things. Replication has its own costs and its own impact. And then you have to look at the actual cost of storage, network bandwidth, et cetera. So what are some strategies that we can use for protecting an application? Now, a lot of people like to say, hey, my application's stateless, and so I can just restore from GitOps and restart the application. If your application really is stateless, then it's a valid strategy. So what's your RTO in this case going to be? How long is it going to take to come back up? It's how long it takes to install the application and for it to get back online. You don't have an RPO because you don't have any data, so that's good. The impact on the application, it's pretty low because this is how you would normally install the application anyway, so you probably don't have to change the application in any way to work with this. And your cost is low. Now, if you actually have data, which many applications do, and hopefully everybody here is here because they actually do have data, then there's other strategies we can use. So backup restore is a pretty common way of doing things. Your RTO, it's going to be however long it takes to restore. So that may involve restoring from snapshots, which could be pretty quick. It may involve rebuilding volumes and reloading the data, which could take longer. So I'm going to say it's medium. Then your RPO, how much data would you lose in the event of needing to recover? That's going to depend on how often you're doing backups. You do it once a day, it's going to be, you're going to lose up to a day's worth of data. You're doing it every 5 minutes, well, you might lose up to 5 minutes. But again, you're going to have to weigh the costs of the storage, how often you're taking backups, et cetera, in order to pick what's right for you. And so you really need to take a look at your application and go, what's the actual impact? If I lose a day's worth of data, is that okay? In many cases, it's not, but sometimes it is. And then our cost, again, I'm going to say this is like in the mid-range because it depends on how much data you have. Now, one option for replication. So replication is where you actually have the data being stored someplace else continuously. So one option is having replication with a cold copy. So there's no compute running in your remote availability zone. So in that case, your RTO is going to be fairly low because you just need to bring the application up. The data is already there. It doesn't need to be restored. You're remote replicating it into persistent volumes on the other side. Your RPO, it'll depend. So you can have asynchronous copies where things are, eventual consistency there. Your RPO will be low, maybe a few seconds to a few minutes, depending on how much data you're writing. If you go for synchronous copy, where every write happens simultaneously in all of your availability zones, your RPO can go to 0, but you may have more of an impact on the application because things have to actually be written in multiple places before you can get back, before the application can move on. Your cost is going to be higher because you've got a lot more, you've got live storage instead of, say, object storage. You've got network bandwidth, and people always underestimate how much bandwidth storage involves. It is a lot. And so your cost is going to be higher there. Then we could have things like you're fully replicated, there's multiple data centers, they're all up and running simultaneously, and you're replicating across here. That's kind of our holy grail for web applications or cloud native applications is to really be distributed across multiple data centers. And there your RTO time is low, your RPO is low, but your costs are high, and you may actually have to do work in the application to make it a fully distributed application. So when we look at these strategies, where are we at for these things? So GitOps, we can do GitOps. Backup and restore, we've added a lot of things into Kubernetes to support backup and restore well. And there's multiple commercial and open source applications for handling backup and restore. And it's fairly well known how it works. And then replication, this is, I think you wind up kind of rolling your own in many cases. So you may work with something like a fully replicated database, and as long as you have like one database, it's fairly easy. You, of course, still have to manage things like failovers and so forth. But there's really not like just an off-the-shelf solution for everything that just fixes it. The other thing you have to look at is if you do go down the replication path, which has a lot of advantages, is it a 100%, do you no longer need backup and restore? I would argue no. And that's because you are remote replicating, which is good. But, for example, say you got a bug in your app that starts writing garbage data into the database. Well, the database will very happily replicate that over. Or if you're using remote volume replication, it'll very happily replicate that someplace else. And then you've got a corrupted database in all your locations. Ransomware is even worse because that's data corruption with teeth. And so you really want to be able to have some immutable copies that you can go back to. And replication, again, it's good, but you have to look at your costs. Storage, networking, and compute costs can be high. So you really have to understand if it's what you need. And then your synchronous replication, that may have impact on your application's performance because it's taking the time to make sure the write's happening in multiple regions before it actually moves forward. So it's really important to understand what your requirements are on things like RTO and RPO before you select a strategy. And then pick the right one that, to match your costs. So we talked a little about consistency earlier, and this is a common theme in backup and restore. And Xing mentioned earlier about crash consistency and volume groups. So in crash consistency, a crash consistent backup is one where when we restore the system, all of the data is basically at the point it would be if you had just pulled the power. So all of you got all of your write ordering correct, everything that was supposed to be written to disk is on disk, and your application should be resilient to crashes. So there's some form of a repair operation that probably has to happen, but with a lot of modern systems, that's pretty quick. You've got logging file systems, you've got databases that do logging, and so it's a relatively fast recovery. And the other thing about crash consistency, and one of the reasons we often do this, is that you can do this with volume snapshots. So we can snapshot a volume at a particular point in time. Everything that was written to the volume is what's going to be there. And snapshots are generally fast. We're talking a few milliseconds in a lot of cases. So the impact on your application is low. So the I/O is paused for a few milliseconds. And I've actually run into cases where customers have been, oh, well, even a few milliseconds is not good. So those are interesting. But in general, it's in that range is the actual impact on the application. One of the issues that we do run into is multi-volumes and getting crash consistency across multiple volumes. And that's something the volume group consistency snapshot will help with. That's going to need hardware support or storage system support to actually snap multiple volumes together. Another strategy for consistency is to be fully consistent. This is where you quiesce the application, possibly even the operating system. And this will get you everything to disk, everything's correct. It's like doing a power down and then a cold boot. Now, the problem, of course, is that if you quiesce the application isn't doing anything or isn't available while you're doing your backup. So, it depends on your needs. Now, application consistent, I don't know, Xing and I were arguing if anybody actually understands what this is. But in my terms here, this is where the application is actually part of the backup. So for example, say you're using a Postgres database and you do a PG dump as opposed to snapping the disks. Now PG dump actually runs at the Postgres level. It's basically a transaction and it dumps out all of your SQL tables. And there's some nice things about this because one, it's in a format that Postgres understands. Two, if there's any replication, you're not getting duplicated data. And in the case of like PG dump, it's actually, you get a performance cost that's small because you're running this big transaction to get everything out, but the database is actually available and you can continue to write to it while it's dumping the data out because it just starts a transaction. So this can be part of your strategy, is figuring out how to use this. And then there's inconsistent backups, which are generally a very bad idea because that means that when you take your backup, it looks great, but when you go to restore it, something says, wait, I can't recover this. I expected things to be written in this order, and they were not, and it dies. So in general, inconsistent backups are a bad idea. There's a few cases like, say, all you're doing is just backing up log data. It might be okay, but in general, it's a bad idea. Now, moving on to actually impact of changing applications. So one of the things we've been seeing is operators. And operators are great. They do some really neat things. They let you build a composable application. And you can do things like build an app that says, hey, I want a database that has this many gigs or terabytes of storage. It should go this fast, et cetera, et cetera. And the operator does the work of standing that up, doing maintenance on it, and so forth. That's great. But then when we come down to, like, for example, backup and restore, some of the issues we run into are things like the operator may be doing things while you're in the middle of your backup. Because when we do a Kubernetes backup, we want to get all the resources out as well as all the data on volumes or in applications. So that may give you an inconsistent result. So if we can quiesce the operators, that would be handy. Another thing that's tricky in Kubernetes is this very flat space of resources. So determining the relationship between things is hard. So we've got, traditionally we had fixed relationships. We had things like stateful sets with pods and PVs, and we understood this relationship. It was kind of fixed. But now with operators, we get a custom resource, and the custom resource may have multiple stateful sets attached to it, and those may have multiple PVs. And understanding that, say, for example, we're using the operator's backup, and that means we don't need to back up the PVs or the stateful sets, that becomes a little harder. So ideally, operators would start tagging everything properly and having some standards for how we tag those. On restore, it gets even more interesting because you wind up in race conditions with the operator. So for example, say you have a Postgres, I love Postgres, you have a Postgres operator and you write, on restore, you write the CR that says database, says Postgres database. Well, the operator, if it's up, goes, hey, let's make a new database. And it creates some PVs, it creates some stateful sets, and then the backup application is like, no, I wanted to write those PVs. And you wind up in this fight. So again, this is where we really need to have this order of restore figured out and being able to understand the relationship between the objects so that we restore them in the right order. Because if the operator runs first, you're going to wind up with an empty database rather than your restored data. So again, being able to quiesce the operator would be helpful. And what we really need to start working towards are some standard interfaces where, as a backup application, it can say, hey, I'm looking at these things, I'm going to go into restore mode or whatever, and put things to sleep for a while. So that's about where we're at on the white paper now. I'm going to hand it back to Xing on other stuff.
Thanks, Dave. So we also have other initiatives in the working group. We started to have discussions on replication, how to replicate volumes, how to replicate Kubernetes resources that are part of the application. This is still at a very early stage. Now let me talk about how to get involved. So we have this community page. You can find information about this working group. We have bi-weekly meetings on Wednesdays. So come join our meeting and learn what we are working on and see if there's anything you are interested in contributing. We also have a mailing list and Slack channel. Here are some other KubeCon sessions. We have a session about change block tracking coming up at 5 o'clock right after the session. So if you're interested to learn more, please join that session. That's all we have. Thank you for coming. Are there any questions?
Well, actually, so wrong slide. Back one more. You could try to do that. So basically your comment here. I'm going to try. So basically the comment was, for GitOps, one strategy would be to use GitOps to restore the application and have the data restored independently or first, and then bring it back up. You could try that. It's a little tricky. So for example, you're going to need to pick all of your PVs, for example. So if a new one comes up, you've got to make sure that one's getting replicated. So what's actually orchestrating the whole thing for you? And basically, you've got backup and restore. It's just you're using GitOps to put your Kubernetes resources back. You also run into issues with applications that may be a little more dynamic. So if they are reading and writing resources, that might.
But that might also kill me in backup and restore. If I'm restoring something that might be old because it's already mutated from something else.
Well, you try to get a consistency across the backup. So you're backing up the Kubernetes resources along with the data. So ideally, it's not too dynamic. You get all of the resources, generally, if you do a Kubernetes backup at this point. So it should be together. So I would put that flavor of GitOps, where you're actually doing backup of the data. You've moved on to backup and restore. It's not necessarily a backup application that's doing it. So you still got, in terms of your RTO, you still got to get all of your data back in. Yeah. But yeah, you can certainly try it. It's challenging, right? I mean, I've been looking at this, when we started looking at this at VMware a few years back, God, 5 or 6 years back, maybe more, everybody said, oh yeah, you just back up all of the virtual disks. And I was like, okay, but wait a minute. Each of those virtual disks, like in VMware, they all have like a UUID. It's like, okay, where do those actually go? How do you stitch this whole thing back together? So that's the thing to look at. Yeah, stitching it all back together can be challenging. Oh, lost Xing. Any other questions? All right, thank you, everybody. Thanks so much for coming. And we're all going to run to the next one on the change block tracking. Thanks.